All right, we're going to go away from sketching parabolas for a moment and revisit solving equations, the type of equations involving something squared or some form of x squared or something squared. Those are known as quadratic equations if you're feeling comfortable with them by now. The type of equations you should be able to solve to succeed in this practice are the type of equations shown in the second video of this series. So check it out if you haven't seen it. And if you're not able to do those, then I would definitely try that before this video. Okay, so I would like to invite you to pause it and take some time to try these by yourself if you would like to. Otherwise, let's check them together. You can check them in your head, all right? So the main idea that we highlighted before is let's think of this as something square equals 81, something square equals 81. Notice that they're the same equation in different format. And it says something square is 81. How many numbers can we square to get 81? There are two numbers. One of them is positive and the other one is -9. Hopefully this is familiar notation to you because we did this in the previous video. And the other way of saying that is something represented by x. It's the same type of solution, a positive and a -9. Remember, we can square those two and get 81. This one has an extra step right here, and you will see that a lot. This is going to start to happen in these type of equations, all right? So I want you to think, if you're confused with this, think of how would you first solve x minus 81 when we were doing linear equations back in algebra? Earlier stages of algebra, how are we solving this? We say, oh, we're going to add 81 on both sides and then we're done. So this is the same thing. Let's do that. Let's add the 81 on both sides. Adding 81 to the left side makes this a 0. So we're just left with x squared equal to 0 plus 81 is 81. But before we would get x equals 81, now we have x squared equals 81. And look, we solved that already. Something squared equals 81. There's one square root to 81. It is 9. Remember that we could have said positive or negative square root of 81, but we can square both of its versions. So that's another connection to make. And I only wrote it like that because I already wrote the answer before twice. I wanted to switch it up. This is the same as that, all right? Don't forget that. And we can apply the same kind of thinking here now that we know how to go about that. Something squared minus some fraction. Don't let the fraction intimidate you. We still want to undo that. How do you undo this negative 25 over 36? We're going to say that x squared is by adding 25 over 36 on both sides equal to that. The nice thing is we had 0 on the right side, so adding it was very easy. And now we ask ourselves, how many numbers can we square to get this fraction as before? The something was either a positive or a negative. Remember, these fractions take the square roots individually. What's the square root of the numerator? It is a perfect square, so we can write 5 instead of square root of 25. And square root of 36 is 6. So positive 5 over 6 or negative 5 over 6 are our solutions. And maybe I can box some of these to indicate we're done. Done with this one. And same here. How do we have something squared minus 8? The opposite of adding 8 is adding 8 on both sides. And then we can say, all right, is this a perfect square number? Yes or no? And it is not. Therefore, the only way to represent this one without using a calculator is to say plus or minus the square root of 8. And if you're more advanced with algebra and your foundation, I know there's other ways of representing this root in a simplified form, but that's not the goal of this video, right? So for right now, this is perfectly sufficient. All right, next thing is 1b. So this was part of, again, if I'm going a little fast, pause it and try them for yourself, then check. If you did that, let's check now. Otherwise, let's still check it. And remember, we talked about this idea already, x minus 12, very similar to this one. So let's solve this one. How do we solve this? Is by adding 12 to both sides, and then x equals 12. And I did emphasize that this is very similar to the one above, but this one has x squared. It has an extra step. So we will do the same type of thinking at first and gives us x squared equals 12. But now we have to ask ourselves, can we get, first of all, is this positive or negative? Is another thing too that maybe we should ask before anything. If this was negative 12, we would be done. Don't forget that. But it's positive. There are two possible numbers. They're not perfect square integers, but we can represent this as positive or negative square root of 12. And that's perfectly sufficient for this problem. Very similar thinking here. Notice that we have 25 minus x. The only advice I would give you is not wrong. I would say don't subtract 25 on both sides because then you still have a negative, especially because there's a 0 here. I would advise that you add x on both sides. That would give us, adding x on both sides would leave a 25 on the left side, and 0 plus x. And look how much easier that was in terms of not dealing with more negative numbers. All right. And then we can apply that same type of thinking here. Because we have positive 25, let's leave that here. And this is already a negative something's x squared. Let's add that to both sides. All right. And that would give you 25 equals x squared. If you don't know what I'm saying, I'm going to write it one time, but I want you to visualize it. It's like we're doing plus x squared on the left side and plus x squared on the right side. I'm not that type of mathematician, but I'm showing it to you in case you are used to doing that. Just know that I say it out loud. I don't ever write it down, all right? But that's what I meant if you needed to see it visually. If you're having trouble with that, then I encourage you to take out your own paper and you write your own plus something on both sides. That's just not something I do. And then I can say x equals plus or minus 5, since I wasted a lot of time with that little speech about that. All right. Same thinking. Look, even though each problem looks more difficult than the previous, they're the same type of difficulty, in my opinion. It's just now you see a fraction to intimidate. But look, it's still some number minus something squared, and there's still a 0 here. So it's very convenient to say, all right, 121 over 64 is going to equal x squared. And that way we know that x is either positive or negative, and those are both nice integer square roots. I'm going to say that x equals a positive or negative 11 over 8. And excuse me, I'm running out of room. I was trying to see if I can fix that somehow. But let's go with that. I think you can still read that. Matter of fact, I'm going to try something. Never mind. So same thinking here, 100 minus something squared. I just want you to think, oh, 100. We undo the minus something squared by adding it to both sides, and we'll be left with something like this. And we've done these type of problems many times. Something squared equal 100. There are two possible numbers to square and get 100. There are a positive and a negative 10 equal to that something. And the reason why I write it like this, we're going to get like x plus 5 or x minus 6 or x minus 7 inside there at some point. All right, but all right, that should be good enough. I'm going to draw a boundary here to separate. Oh, there we go. That worked out way better than I expected. Okay, we can still read these very clearly. Again, this is just to kind of warm you up and get you some reminder as to what we did in the previous video with a little bit more, all right? And it's going to get more complex as you see. Number 2 already has more going on than the last video. That's why I advise you to not start here unless you're already very comfortable with it. And again, we will think something squared. Let's get started, or positive if you need more time. Something squared equals 1. We've done similar things to that. Something equals plus or minus 1. Done. But remember, there's something more going on in the next one. But still, we will think something squared equals 1. So then we can say something equals a positive or a negative 1. But now we ask ourselves, what's the something inside? The something inside is a x plus 1, which just gives us an extra step here. How do we undo the plus 1? Yeah, these are not new. I don't know that we need more time to go over these. And remember, at this point, we're just going to leave it like that up to now, okay? In the next video or two, we will worry about simplifying those. Okay, especially because look, a lot of the time, we will get numbers that are not perfect square integers, such as 23. So then we can say positive or negative square root of 23 are the possible two values to square to get something. Remember, still something squared equals 23. What's the something inside? It is still x minus 2. And then the last thing to undo is subtracting 2. So therefore, we will add 2. So 2 plus or minus the square root of 23 equals x. Notice that I didn't write plus 2 because this is the first time it's already implied, all right? Just as a note, especially for this one, because I do see my students from time to time say plus or minus 23 square root of that. Plus 2. That's also correct, but look, that just looks a little more confusing, which is why I wrote it in the form above. But just know that it's not wrong, okay? I just won't always be doing that. I won't be writing 2 ways of writing it every time. You should hopefully be able enough in your math abilities to understand that these 2 are the same. I just wanted to confirm it in case you were doubtful. But let's move on. Same idea. I have something squared minus 3. Let's target the minus 3 part first. How do we do that? By adding 3 to both sides. Be very careful. Make sure you do this correctly and check my work as well. Something squared equals, adding 3 gives us a 39 on the right side. And we're left with the something squared on the left side. something squared equals 39. That's not a perfect square integer, so we're going to say that something equals a positive or negative square root of 39. And what's the something? X plus 4. So one last step to do here. How do we undo the adding 4? We're going to subtract that 4 to both sides of the equation, and it should look in the form negative 4 plus or minus the square root of 39. And done. Look at that. That looks already very advanced and complex, but it is not the precise answer using a calculator, but the two answers are represented here. Same here. This is not simplified, but the two answers are represented perfectly. All right, next. Even with this, I think I might want to simplify one of them. If that is the case, I will simplify this one. This one means something squared equals 16 over 25. We've done things like that, hopefully enough times to be comfortable. We know that something is either a positive or a negative version of the square root of that fraction. And both numerator and denominator are perfect squares. So hopefully you are thinking positive and negative 4 over 5. And we're done with this for now. But look, the next problem resembles the last one very much, which is the main purpose of that. And let me see if I can give myself more space like that. There we go. And try. Okay, here we go. Again, we're going to think, we already did the thought process. Something squared is that fraction. We get that the something is plus or minus 4 over 5. But we have an extra step. What's the something? Negative 2 over 5. And how do we undo subtracting that fraction? We are going to add it to both sides. So therefore, we get x is equal a positive 2 over 5 plus or minus 4 over 5. And this one I will simplify because it's fractions and you might be intimidated. Let's have a little fun with this. Remember that this means two options. It means either x is 2 over 5 plus 4 over 5. And the other option is that x is 2 over 5 minus 4 over 5. Those are the two solutions represented, but because they have common denominators, that was very nicely written by the author. We know that we can simplify those. The common denominator is 5, and then 2 plus 4, 2/5 plus 4/5 is the same as 6/5. And that's one of the solutions, simplified. And the other one is 2/5 minus 4/5. That should be the same as negative 2/5 or negative 2 over 5. And those are the two solutions, simplified. These are the simplified forms of the solution. This is the represented form, okay? I like the represented form most of the time, unless it's a task where they're asking me to label x and y intercepts. Then that's when I usually do use the simplified form. But let's continue. 2b is very similar, but nothing like we did in the first part of the warm-up. 49 minus x, we're going to add x to both sides. So that gives us 49 on the left side and adding x to the right side. Done. So that when we see quadratic equations involving something squared and a 0 and that negative something squared, that's what I'm having you try to look for. So that way we can say 49 equals positive something squared. And then we can say, all right, something equals a positive and a negative 7. And remember that what's in here is going to be more advanced, just like right here. There it is. All right, so then we can do the same kind of thinking. Instead of subtracting the 49, we're just going to add this whole thing to both sides. The negative something squared, let's add it to both sides. And that something is still x plus 5. But still, we know positive and negative 7 equals to the something. We already did that thinking right here. And now we have one further step. How do we undo adding 5? We're going to subtract 5 on both sides. So now I can say negative 5 plus or minus 7 equal to x. And those of you curious in simplifying these, I won't write them down, but I'll check them for you. One of the answers should be negative 12. I got that negative 5 minus 7, and the other one should be a 2. I got that by doing negative 5 plus 7. Excellent. 3 more type of varieties, but these are all already pretty advanced. So let's see how we would go about that. Something squared minus 10, we got to undo the minus 10 first by adding 10 to both sides. So just make sure you do it carefully. I like to do it in my head. As I mentioned, if you like to write the plus 10 on both sides, make sure you do that and get a 36, because look, 26 plus 10 is 36. What's the something inside? x minus 2. And then I think what something squared equals 36. What two things can we square and get a 36? That something better be a positive or a negative 6. And the something, x minus 2. And then how do we undo subtracting 2? We're going to add 2 on both sides. X is a positive 2, positive, subtract, and add 6 to that. If you do that, I'm going to box it here. This is a represented solution. Those of you that like to check, one of the answers is 8. The other one is negative 4. If I made a mistake, let me know in the comments, but I won't write them down. All right, because that's not my goal for this one. And look, here's what I want to point out. Even though I highlighted that the fact that this is 0 and I have a negative something squared, this is happening, the minus something squared, but there's no 0 here. I think that even then, I prefer to do that. So I'm going to think, let's add this whole thing to both sides. So if we add positive something squared on the left, we just remain with the 40. And then we get that positive something squared plus 15 on the right side. And what's the something? It is still x plus 3. So all I did right now is just rewrite the equation in a different way. But I'm no longer thinking of negative something squared. What I'm going to think instead is I'm going to subtract 15 on both sides. Now let's subtract 15 on both sides. And that would give us 25 equals something squared. The something is x plus 3. And maybe you should take it from here. Don't forget, what's the something? And last step. There it is in represented form. Negative 3 plus 5 should give us a 2. And negative 3 minus 5 should give us another solution of negative 8 if you're checking. All right, how would we do this last one on number 2? I see it as something squared minus 19. Of course, we're going, and a 0, that's perfect sign to do that. Something squared equals 19. And the something is x minus 6. And 19 is not a perfect square integer. Hopefully you can recognize that and say the something is a positive or negative square root of 19. The something is still negative 6. And last step is how do we undo subtracting 6? We're going to add 6 to both sides. 6 plus or minus the square root of 19 are the two represented solutions. If you want to check that, then you need a calculator. I don't have one in front of me right now, other than my brain calculator. And my brain calculator is not that fast for radicals like that, or square roots. So as long as you get to the represented form, you're in great shape. And last thing is just a variety of all of them, all right? If you're successful in these, it's gonna make our next 2 lessons that much more enjoyable and easy. So see if you can identify what to do with each. Pause it and try yourself if you need to. If you did, welcome back and let's check now. Otherwise, check in your head. Some of us and some of you can't do that. I will start by undoing the plus 3. Something squared equals, be very careful, what's 44 minus 3? Not plus 3, 44 minus 3, I believe is 41. And then I would recognize that this is not a perfect square integer, so the only way of representing our 2 solutions, plus or minus the square root of 41. If you got that one, it's one of the most basic ones, but you're in good shape. Then we have something squared minus 6 equals 12. Same format as the other one, pretty much. Let's undo the minus 6 by adding 6 to both sides. X squared is, be very careful, 12 plus 6, huh? Not minus 6. It's 18. And then x is a positive or negative square root of 18. Is that a perfect square integer? It is not. So therefore, I'm going to stop right there. And if you know how to simplify that into some form of radical 3, that's you're ahead of the game. That's for another lesson for me, though. All right, and same format. I'm starting to notice a lot of same format. Plus 5, let's subtract that. So let's speed up. X squared equals 15. And again, that's not a perfect square integer. Therefore, x is positive or negative square root of 15. Boom, done. All right. Oh, but that's why we did that. Look, something squared plus 5 is 20. And then something squared plus 5 is 20. Hopefully you recognize that. So we will say something squared equals 15 and look for the similarities between these two. Right? And then we can say the something is x minus 3. What are the 2 possible things to square to get that? We already knew it was positive. Negative square root of 15. The something, it still remains x minus 3. And the last thing to undo is subtracting that 3. What's the opposite of subtracting 3? We're going to add 3 on both sides and get a positive 3 plus or minus the square root of 15. And again, notice how I didn't put a positive symbol. It's implied. I must only put that symbol in front if it's a negative. There's no other choice. So there it is. This is the represented form, and we're doing great so far. 3 more problems, and then we can call it an end to our practice. Let's see if you can do them faster and quicker than I can. Something squared minus 6, we're going to undo that minus 6 for sure. So something squared is 51 plus 6 should be a 57. The something is x plus 7. 57 is not a perfect square integer. So x plus 7 is plus or minus the square root of 57. Therefore, x should be a negative 7. Notice how now I do write the negative 7 plus or minus the square root of 57. If you got that one, you're in great shape. And then 2 more. Again, I see my favorite scenario. There's a 0 and there's a negative something squared. This one's going to work beautifully. 16. Adding this something squared to both sides, the left side just remains with 16 and the right side becomes the positive version of that. And therefore we can say what 2 numbers were squared for a 16? A positive negative 4 equals the something. The something is x plus 5. And the last thing to do is to undo this plus 5. How do we do that? By subtracting 5 on both sides. And we're done with the represented form. If you want to check, one of the answers is negative 9. And the other one is negative 1. Okay, lastly, not my favorite scenario because it's almost there, but that's a 9. And the previous one is 0. But I think I'm still going to do that. I'm still going to add the something squared to both sides so that we get a 20 on the left side. And then something squared, because this is a positive 9, I'm going to say plus 9, not minus 9, all right? And then the something is x minus 3. Then I see it like these type of problems. We're going to undo the plus 9 by subtracting it on both sides. 20 minus 9 should be 11 equals something squared. And the something is still x minus 3. The 2 possible numbers to square and get 11 are positive, negative square root of 11 equals x minus 3, which is the something. And therefore, x is positive 3 plus or minus the square root of 11. Let me make sure the 11 part is right, because I would hate to get this far in the video and not catch that mistake because I didn't take a little bit of time to check. Yeah, that looks right to me. If not, let me know what the correct integer should have been, but the concept is correct. I know that for sure. All right, thank you for your practice today. I hope that you're gaining comfortability, and I promise you everything that we've done up to this point is going to be put together very, very soon in a cool way. So tune in on the next one and have a good rest of your day.